Afternoon, everyone. You are welcome to our training session from IOC project. This training is focused on Phobos object store on tapes. This is the third training online session, and the session will be done by Guillaume Courier and Sébastien Gougeot from CEA. I hope my pronunciation was not wrong. So the program is the following. This training event will take 2 days, 2 3-hour sessions. Today, each session, each day will be divided to the presentation at the beginning, and after the coffee break, there will be a practice session. Today, you will hear about the state-of-the-art of storage architectures in HPC and the needs for developing Phobos. You will hear also about the basic set of features like managing types on a virtual tape library, get objects to and from tapes, managing POSIX file systems, and so on. And also you will practice storage technologies, basic I/O libraries, management in virtual environment, and so on. And tomorrow the session will be focused on Phobos tuning, on advanced Phobos features like resource stacks, versioning, object deletion, and you will exercise solving some small issues in Phobos system. And but first, let me introduce a bit our IOC project. So only shortly, the project is focused on storage I/O and data management for exascale architectures. Together with projects DeepC and RedC, these third projects all address modular supercomputing architectures. DeepC is focused on software for exascale architectures, RedC for on network solution for exascale architectures, and IOC is focused, as I said, on input-output software for exascale architectures. The project consists of 10 partners, and the project coordinator is CEA. And here you can see the goals of the project. The project is focused on design and development of a novel management and storage platform, which includes usage of different types of object stores, taking into account hierarchical storage management and on-demand ephemeral provisioning of storage services and scheduling, and also co-design with the next generation IO-intensive HPC-oriented applications. And here on the scheme, you can see that the project deals with different levels of storages with the different data temperatures. And today we will focus on that level of cold and frozen levels of the storages. So this training event today will be led, as I said, by Guillaume and Sébastien. Guillaume Courier has been a developer at CA for 2 years, working on Phobos and Robinhood. He also contributes to Lustre development. And Sébastien Gougeot works at CA for 3 years in HPC division. He is currently a software developer working on Robinhood and Phobos. He also leads the research of a team of data scientists to use machine learning algorithms to better understand and manage computation clusters. So, Guillaume and Sébastien, the floor is yours.
This training is part of the IOC project. And one of the goals of the IOC project is to support the incoming exascales that the future HPC architecture should be able to handle. And with exaflopic supercomputers, we should expect to have also exascales of data to handle. And for that, we have two problems to solve. One is to be able to access any data quickly, but also to be able to store all the amounts of of data that we have to handle. And if you go to the next slide. So for the efficiency of the data access, what Phobos does and what IOC also tries to do is to get rid of the legacy POSIX file system and use object store types of addressing to access the data. This reduces the complexity of the system, but also removes the bottlenecks that can exist in POSIX file systems due to all the metadata synchronization. And so that's one of the reasons why Phobos is used in IOC as an object store. So if you can go to the next slide. But for the, as Katerina said, Phobos is used to store, because it's able to store data on tapes. And why is it important? It's important to be able to store data on tapes, especially if you want to store exabytes of data, since the cost of having an exabyte of storage on disks or on flash would be too high, especially in terms of energy consumption. The advantage of a tape library is that the data that is not used is just idle in the library, and you don't have to consume energy to keep it available. So for those who, I don't know if everybody knows what a tape library is. So a tape library is basically, as you can see on the right, it's a sort of huge box that contains a lot of shelves on which you can see that there is a tape. So depending on which library you use, you can have one or several tapes on one shelf. And you have a robotic arm that will take the tapes and move them into the drives. And so the drives will be able to read and write data on those tapes. And so, as you can imagine, the cost of reading data on one tape is significantly greater than compared to a disk or flash-based technologies. And that's why the data that's stored on tape is the so-called cold data, because you don't want to access that data too often. You can go to the next slide. And so why do we started to develop Phobos at CA? So there already exist some solutions to store data on tapes. And so what we are talking about here is the software that's able to control the tape library and ask for the movement of tapes and reading and writing data to them. So, but those solutions are proprietary, often very expensive in terms of licenses, but also in terms of maintenance. You need experts on those softwares to solve complex issues. And they are also quite heavy to install and maintain. So we started to think about other alternatives for managing tapes. So you can go to the next slide. So introducing Phobos. So the main goal of, so first of all, the name Phobos stands for Parallel Heterogeneous Object Store. So why heterogeneous? Because although the main role of Phobos is to store data on tapes, it's also able to store data on other medium, as you'll see in the practice session. And in particular, we can store data on any POSIX file system, which means that we can store data on disk or flash, on tapes, obviously. And we also recently added the support for the Rados object store. So we can also store data in a Ceph-RADOS environment. And the goal is that Phobos will try to optimize the data access on each of these technologies. So the main optimizations that have been done in Phobos right now are based around tapes. And so, for example, we want to minimize the movements of tapes in the library and avoid unnecessarily load and unload operations. But also when we write data to tape, there is some synchronization metadata that needs to be written. And we also want, for example, to minimize those operations as they can be quite long. To give you an idea, loading a tape can take a few minutes, and a data synchronization can take up to a minute as well. So this can be very long, especially if some job is waiting for that data, for example, to be read. So you can go to the next slide. So quickly, some of the guidelines that we try to follow when implementing Phobos. So obviously, as we are in HPC world, Phobos should be scalable and fault tolerant. So as you'll see, it can be scaled up. It can scale up using more nodes, more transfer nodes. We also use open formats, so such as LTFS. LTFS stands for Linear Tape File System. So it's a file system that's implemented in using the Fuse user space API, and so that's the data layout that we use on tapes. And we try to keep Phobos as simple as possible. And as you'll see, Phobos is not a solution that you can just install and it runs. You have to build compatibility layers if you want to use Phobos in any system. You can go to the next slide. So a bit of history. So Phobos started at the end of 2014. I think the first commit is of December 2014. And initially, it was a command line interface, and it controlled the tape library and used LTFS to store data. And it was in production since 2016 for a project called France Genomic. And it has a few petabytes of data. A few petabytes of data have been written since then. It has been made open source in 2019, and we are currently working on the version 2.0 that should be a fully distributed version of Phobos, with also a lot of I/O optimizations on tapes. And we are also in the process of using it behind a Lustre HSM file system. You can go to the next slide. So now, how does Phobos works internally? So Phobos is composed of three main components. So the first component is what we call the client. So it's composed of the user interface, or the compatibility layer at the top. So we provide a command line interface and a C API as well. But we also have an S3 front end that's called Deimos. We also support. We also can use Phobos as behind an NFS Ganesha server. And since we are using Phobos in production behind Lustre HSM. We also have a Phobos copy tool that's able to copy data from Lustre to Phobos and vice versa. And so that's the entry point of the client interface. And so once the client has started, for example, a put or get operation, we will enter the object store layer just below. That layer is responsible for handling the creation of new objects or the query of the metadata of those objects, for example. And if we are trying to read or write data, depending on which layout we have, so we currently only support mirroring, so red one layout. The client will communicate to a server, and so that server is the resource scheduler just below. That resource scheduler is the only component of Phobos that knows how to work with the underlying storage devices. So for example, that's the component that will move tapes around in the library. So it will send SCSI requests to the library to load and unload tapes, for example. And so as I said earlier, so the layout will, depending on the layout, it will create different types of requests, saying, for example, I want my object to be replicated twice. So it will create a request saying I need two tapes, for example, to write data. That resource scheduler will schedule the request and maybe wait a little bit depending on what's the most optimal scenario for the, depending on all the requests basically that are sent to that server. And once the request is ready to be handled, the client will receive the list of tapes basically that it can use to read or write. And then we will enter the right part, sorry, of the graph, so the IO adapters, which depending on the media that's used, so if it's a tape or a disk, for example, we'll use a different interface to write data on the medium. So for example, if we are writing on tape, we will use the LTFS IO adapter. And finally, the last component that I didn't talk about is the one at the left. That's the metadata, that's the component that contains the metadata of the system, but also all the information about the available media and tapes and the usage of those media. And so that's basically currently a PostgreSQL database that will contain all of the information that's necessary for Phobos to operate. So maybe I can stop a few minutes here if there are any questions.
None on the chat, yes. But if you have any question, feel free to ask it on the chat, and I will relay it, or Guillaume will read it further.
Okay, so
can you hear me? I may have a question.
Okay, yeah,
yes,
we hear you.
Oh, yeah. Sorry, I wasn't sure if you can hear me. Quick question: does Phobos provide services similar to hierarchical storage management, HSM, in short?
HSM capabilities?
Yeah.
Not yet. That's something we want to add to Phobos, but not yet.
Okay, thank you.
At some point, Phobos will need for example, a disk cache to reduce the load on the library, because the write, I mean, the library may be too slow for the load that's imposed by the system. So, and you need HSM features for that. And I see in the chat a question about the layouts. Not all the only layout that's currently implemented is the mirroring. We plan to implement erasure coding within 1 or 2 years. I don't know how the roadmap will evolve, but that's one of the next features we will implement. So can the client-server communication be done through the network? So currently, no. The client is local to the server that's doing the transfer. So in the case of Lustre HSM, for example, it's the Lustre client is mounted on the same server as the server that have access to the library. And for demos, for example, it's the same architecture. Okay, so maybe I can continue. Okay, so I think you can go to the next slide. Okay, so that's a small slide to explain the next features that should be implemented. So we are, as I said, currently working on the optimization of the I/O scheduling. So one of the optimization that has been done is to be able to group the get operations that target the same tape, so that we only load that tape once, read all the data we need, and then unload it. This is what will help to minimize the number of load and unload operations. But we also work on global I/O strategies. So there's a feature called locate that will be able to tell the upper layers basically where data is available and which Phobos node is the most appropriate to do an I/O. We are also working currently on the media, what we call media life cycle. So it's something that's very important when we work with tapes, because it's not easy to remove data from a tape. You can't just remove blocks and reuse them. So what you have to do in practice is once you have a tape that contains a lot of objects that have been erased or that have been overwritten, you reread all the objects on the tape and you write them on a new tape, basically. So that's what we call a repack, and that's part of the next features that we will implement. And so, as I said, internal internal data migrations as well. And yes, a few other important features such as erasure coding and new front ends as well. You can go to the next slide.
Okay, just before we have a question from Dusan. Can Phobos with Lustre use Lustre like LFS, HSM, XXX commands to archive and recall the data?
Yes, that's exactly how you would manipulate data between Lustre and Phobos. Right, so as I said, it's in production since 2016. for the front genomic project, and so we have, I think it's a bit less than a bit more than 3 petabytes of data handled by Phobos. And it's a very simple setup where the raw data is directly written to tapes. And on another data path, I guess, the data is stored on another storage system, and then the compute cluster will analyze that data. So Phobos is just an archival system in that setup, and the data is only mostly written, not read. You can go to the next slide.
Yeah, just before another question from Stefan. How is HA? I'm not sure about what HA is. Handle with Phobos data movers. High availability. Yeah, thanks. How is high availability handled with Phobos data movers? Thinking in FC SAS environment where tape drives are accessible from multiple data movers. If a data mover crashes, for example, will Phobos handle that yet and access the tape drives from other movers?
So that's something that we have already talked about internally. So currently, the only thing that you could do with Phobos is have, so if one of your nodes cannot access some drive at some point, what you can do is remove that that drive from the node that's broken, and put that drive on the other node, because you can't have Phobos doesn't yet support the same serial number at on different nodes, basically. But what you can do is remove a drive from one node and move it to another node. Yes, outside of Phobos, yes. Okay, and for the interest of Phobos in the community, so we already had a collaboration with iCheck and DDN, and they implemented a feature called Alias that you will see tomorrow, actually, and also, as I said earlier, the Demos S3 server, and obviously IOC as well. We are using Phobos as the cold storage of IOC. You can go to the next slide. Okay, so now we start talking about concrete examples. So first of all, Phobos only uses one config file. That's one config file per node. And it's a very simple key value ini syntax. And that config file will contain one of the most important element of the config file is the connection to the database, obviously. That can be the database can run on a different server than the transfer nodes. And we have also a lot of tunings. So in the new versions of Phobos, we will have IO scheduling optimizations. So as I said, grouping requests per tape, and also some synchronization parameters. I will probably show you those parameters later. And also a lot of tunings about the SCSI communication. So the libraries use a SCSI interface to control them. And there's a lot of small parameters that you have to optimize have to choose for that. All the LTFS specific operations, and also the compatibility rules between tapes and drives. And we have also a lot of parameters on the store layer, so parameters about layouts, alias, and some IO parameters such as the block size and things like that. I can go to the next slide. So as I said, there's a server that's the Phobos daemon, Phobos D. The client will communicate with the server. So obviously for put and get operations, the server will choose which physical media is used to write or read data from. There's also an operation to format a tape, so we will see this operation later, which also needs the presence of the daemon. And then there are a lot of administration commands. When you add a drive, for example, the daemon is notified so that it can add the new drive in the list of drives it can manipulate. And the same when you remove a drive, you have to tell the server that the drive does not exist, cannot be used anymore. And most of these commands can work depending on the current setup. If the daemon is not up, those commands need to tell the daemon that the state of the system has changed. And yeah, that's okay. You can go to the next slide. So when you're using a tape library, you have two resources to manage. One is the drives. So you simply, when you want to add a drive to Phobos, you simply have to add the drive. So Phobos drive add. In this example, it's the path to the ST Linux device. In practice, you can also use the serial number of the drive and also the path to the SCSI generic device as well. And then when you want to add a tape, again, you just have to import the tape into the database. So using the Phobos tape add specifies, basically all the tapes between the 0 and 22 tapes. And then so for a drive, you only have to add it, but for a tape, you have to format the tape before you can use it. And the format operation is basically an LTFS operation. So Phobos will format the LTFS file system on the tape. And once this is done, you can start writing on that tape. And after that, you can also read data from that tape. We also support two other types of what we call media, so the storage devices. So we have tape, dir for everything that's POSIX specific, and we have also Rados pool for the Ceph Rados object store. For dir and Rados pool, you don't have the same as for tapes. You don't have a drive associated to them. So yeah, you can go to the next slide. You can add or remove tapes from the system or even drives. So if you know that some drive has a mechanical failure, you can remove it from Phobos temporarily or definitively. As I said earlier, this operation is dynamic, meaning that the local daemon will stop using that drive as soon as you run this command. And the same goes for tapes. You can lock any tape and also any directory or any Rados pool using those commands. can go to the next slide. Now those commands are the commands that list all of the resources that are inside Phobos. So I'll show you some examples later. But basically, you can list the drives, the tapes, the directories, and you can also list the objects that have been written and the extents. So an extent, we'll see how this works later, but basically an object is composed of one or several extents. An extent is the data that's physically written on the media, while the object is the logical entity above that the user wants to manipulate. And these commands have a few parameters. You can choose, as you'll see, you will have a lot of fields, and you can choose which field you want to display. And you can also change the format of the output. And all of those commands have basically all of the Phobos commands have a helper. But the list command, on the list commands, you have some additional filters that you can use. So for example, I put here the extent list, so you can filter the output, for example, using the name of the media. So for example, this command that's displayed will output all the extents, all the objects, sorry, that are written on the tape that's given here. So you can go to the next slide. So this command, drive status, so that's a command that only works on drives. You don't have an equivalent for DIRs and Rados pools. And that's a command that's that aggregates a lot of information, of useful information about the state of the different drives. So the first column is the address of the drive. That's something that's useful if you want to manually load or unload a tape. You can use there's a command called mtx that uses those indices, so it's easier for the admins to know that address. Then you have the device that's used by LTFS to manipulate the drive. Then if a tape is loaded in that drive, you will see the name of the tape. If the LTFS file system is mounted, you will see it there. Then you have the name of the drive, so that's the name that you used to add the drive earlier. The serial number as well, that's the unique identifier of the drive. And you have also the information whether there is an ongoing I/O on the drive. So if there's a client that's writing or reading data on that tape. And one thing to note about this command is that you need the daemon to run it, because some of those information are internal to the daemon. You can go to the next slide. Okay, so now that we know how to add a tape, a drive, and all of that, we can start writing data on those tapes. So that's the command line interface. So that's not necessarily what you would use in production, but for testing, it's good enough. So the put operation takes a path to a file that you want to write in Phobos, an object ID, and you can also add metadata that you attach to that object. So for example, you can have a checksum, the name of a user, the time of creation. You can add what you want here. You can consult that metadata using the getMD command. The metadata is stored on the tape and in the database, so you don't need to load the tape to know the metadata. but it's also safely stored on the tape. So if you lose some part of your database, you still have the metadata written somewhere. And you can also, so as I showed you earlier, you have some additional filters for extent, and here you have an example of an additional filter for the object list command. You can filter on metadata, and you can also, in this example, list all the objects whose ID start with obj. You can go to the next slide. And so then the reverse operation, reading data. So you specify which object you want to read and where you want to store the object. And you can also write multiple objects in one command. So you basically put in a file the path of the file you want to write, the name of the object, and if you want, you can add also some metadata. And then you just have to pass the path to the file to the input command, and it will write all the objects. And so as you can see above, the object list command will display both objects with the metadata. And I think that's the last slide. Yes.
And we got a question from François. Can standard S3 commands such as AWS also be used?
I don't have the answer to this question. I think it depends on how Deimos is implemented, and I've never tried Deimos, so I don't know.
Is Phobos able to manage multiple libraries? What
Not
do you
yet.
mean by libraries yet? Yeah, multiple robot libraries. Yeah.
Not yet. That's part of the future improvements. Currently, the path to the library is stored in the configuration, and you can only indicate one library, so not yet.
So, is there a notion of bucket in Phobos? The answer is no, we do not. What we suggest, and I think that's how Deimos is implemented, is that the bucket information are stored in the user metadata. Yeah, and you have the information from bucket from iCheck, which implements Deimos. Another from Deepak, how many tape cartridges comprise a typical library? So Guillaume, do you have information from?
I think the one we have are we have several thousands of tape cartridge. For example, for France Dynamic, I think it's a bit more than 1,000, but it's not a huge library.
And another question from Antoine. Can we describe the operation with several data movers? How to know on which data mover to launch put-get? That's some information that will be answered tomorrow, if I guess well, when we will present how we can construct a distributed version of Phobos along multiple servers. And so how to use the get and put operations on those. And then a question from Belzac. I'll let you answer it, Guillaume.
So what exactly is the state of tape usage optimization except for using ATFS, and how do you handle lack of space reclamation at the moment? Okay, so for the optimizations, I'm not sure what you mean by tape usage optimization. If you mean IO optimizations, as I said, we do, when reading, we try to minimize the number of load and unload operations. And on LTFS, there is an optimization that we do that's so basically when you write something to a tape using LTFS, you have to update the namespace, and that operation can be quite slow. And so we try to basically write several objects before synchronizing the namespace. We are also currently trying to optimize the usage of the different drives. So how many drives will write data, how many drives will read data, so that we can adapt the read and write speed depending on the load of the system. And there's also some optimizations done at the level of several, if you're managing several nodes, that I think Sebastian will describe tomorrow. So for the, if I understand correctly, you're talking about the repacks that I talked about earlier. So currently we don't do repacks. So basically the data, we don't do any optimizations, I guess. But in the goal is that we provide a lot tools and ways for the system administrator to know which tapes have the most fragmentation, and then we can have policies to say I don't know if every day repack I don't know 10 tapes or whatever. Does it make sense to want to encrypt data on tapes with Phobos? That's not something that we have planned to implement. Right now, Phobos is only used as an archival system, so I guess if you really want data to be encrypted, maybe you could write a copy tool that, I mean, it would be the responsibility of the upper layers to provide encrypted data, but that's not a feature that we plan to implement. Yes, and Sebastian, Stefan Thiel, sorry, pointed out that the encryption can be done by the drives. I think I missed a few questions.
I think there is only one that was not answered from Dusan.
Is Phobos capable to automatically manage sparse records on tape when some objects extant are removed? So I think this question is linked to the repack. So the short answer is no, as long as we are not able to repack data. Basically, as you remove objects, the tapes have more and more fragmentation. But also, since we don't fully support yet the repack, you can't really remove an object from Phobos. As long as the tape is still available, you can always read the data from with Phobos. But that's one of the next features that we are planning to implement. So the first thing we need to do in order to set up Phobos is to set up the database. So this is a setup from scratch. So this is something that you're supposed to do only once when you want to set up Phobos. So do you see the screen updates as I type, or?
Yes.
Yes, okay.
Yeah, it
So
works.
the first, so we provide a script to help you set up the database. So this first command, so the script is phobosdb, and the first command has to be run as Postgres because that's the user that PostgreSQL uses for the management of the databases. And so basically the setup db command will create the Phobos database and a few other setups. Et pourquoi? Ah oui. I forgot to install the RPMs, so it doesn't work. I had to reboot my PC in order to share my screen, so
There is a chance the command was already launched in the VM, so you already have this the DB ready.
and it will ask you a password. You should put in Phobos because that's the default password we use. And maybe I can show you the config file quickly. So as you can see, that's the string that's used by Phobos to connect to Postgres. And so the default password is Phobos. Maybe I can show you some of the important configuration parameters. I won't explain every one of them because there's quite a lot. So the question earlier about the support for several libraries, this is the /dev changer is the path to the device that will take the SCSI requests and send them to the library. And so currently we only support one library, and one of the reasons why we do is that this path is only you can only set one path basically. These parameters, so sync time ms, sync nbrec, and sync w size kb for kilobyte. These are the LTFS synchronization that I talked about earlier. So this basically tells Phobos that you have to synchronize the LTFS namespace every 10,000 milliseconds. This parameter says that you can write 5 objects between each synchronization, and this is the size that you can write between each synchronization. So basically, as soon as one of these thresholds is reached, Phobos will synchronize the LTFS namespace. And so tuning these parameters will allow you to have better performance or more reliability, depending on what you want. A quick note is that a thing to note is that LTFS will do a synchronization when you unmount the file system. So even if Phobos crashes, as long as LTFS is still running correctly, you should not lose that data. So these are the configuration parameters for the SCSI interface. It turns out that these parameters can be very important because it dictates how, depending on how responsive the library is, you can have a lot of timeouts, and having smaller timeouts means that you are more efficient, but you may be, if they are too small, you will not be able to use the library correctly. And the other parameters will be explained tomorrow by Sebastian. And the last parameters, you should not have to modify them too much. they are basically all the compatibility rules between the drives. So this is the list of LTO5 drives that we support and other technologies. And this is the compatibility between the tapes and the drives. So for example, you can use an LTO6 drive or an LTO5 drive to read or write data from an LTO5 tape, for example. So these parameters, we try to keep them up to date as we update the version of Phobos. So you should not have to modify them too often. Right. So now that we have the Phobos database set up, we need
just
to...
before, Guillaume,
Yeah.
we had a question from Stefan. You talked during the show of the configuration file about synchronizing the LTFS namespace.
Yes.
And you wanted to have more info.
So basically, when you write, so LTFS is a file system, so it needs to know which files are written on the tape and where. And when you write a new file to LTFS, you are not guaranteed that this file will appear in the new namespace. It depends on how you mount the LTFS file system. So one option is to update the namespace each time you close the file, which means that as soon as you've closed the file, you know that the file is safely written on the tape. But Phobos doesn't do that because the synchronization can be quite long. It can take up to a minute. So what we do instead is that we explicitly synchronize the namespace by setting a particular extended attribute at the root of the file system. And that operation will tell LTFS to rewrite the metadata on the tape. So the object is safely stored only when that synchronization is done.
Thank you.
Okay, so now that the database is created, we can set up the tables. So now we have everything that's set up for the database. So what I will do is first show you how Phobos works using the directories. So one way to know if the database works properly is to just try to list something. So if I do an object list, it will query the list of all the objects on the database. So currently I have nothing. If that command fails, it means that the database is not set up properly. Okay, so the first goal I have is to be able to run this command. So I want to write an object, and I want to write it on a POSIX directory first. So if I run this command, it will not work. Why? Because there is no daemon running. And as I said earlier, Phobos needs the daemon for the put, get, and format operations. So I can start the service. We have a little command that's able to send a simple request to the daemon to see if it's running. And so we can see now that the daemon is running. But we cannot still write data to data since we don't know, since Phobos doesn't know where to write that data. So what we can do is create a directory. And we can add that directory to Phobos. And so as you can see, the directory was added to the database. And so now we have a command that lists all the directories, and we can see that Phobos demo is inside. We can also list all the information about that directory. So it's quite verbose, so you won't be able to read quite easily. But what we see, what the most important parts, so there's a field ADM status that is currently set to locked. So as I said earlier, you can lock or unlock a resource, and by default they are locked. There is the file system status that's currently set to blank, which means that we currently can't write data on that directory. And we also have information about the volume that's currently used. So that's the volume used, free, and we also have logical space. The distinction between logical and physical is useful for the tapes, because a drive will try to compress the data when it writes the data on tape. So you will see a difference between the logical space, which is the volume, basically, for example, in this case, of the files that I want to add to Phobos, and the physical space, which is the space that's actually used by the data on the tape. And we have, and so I think that's the most important statistics that the most important fields. So now, if you want to,
we have a question from Dusan. If you have the answer for that, in this case, I can check. Can we support also other type drive vendors like IBM Jaguar, TS11XX drives?
So for I don't know the exact list of what's supported by Phobos. For the tapes, it's basically LTFS that does the work of communicating correctly to the library and using the drives properly. So in principle, we support all the drives that LTFS supports. So I don't know if that particular drive is supported, but since it's an IBM drive, I guess so. And for the libraries, we try to support every libraries. There's a standard SCSI protocol that's used by libraries. There are a few differences between some libraries. So maybe some libraries don't work quite well, but all the libraries that we have available, that we have tested Phobos on, work, basically. So I don't know if that particular drive works or not. Okay, so the next step is to format the directory. So this operation is not, doesn't do much for POSIX directories. The only thing that it does is, as you'll see, so maybe I should do something like this, just to make sure. So currently my directory is empty, and if I format the directory, Phobos simply added a small file that's just a sort of security to make sure that we are writing in something that belongs to Phobos and not writing data to any POSIX directory. But that's the only operation that's done when we format a directory. Formatting a tape is a different operation. And so now the only thing that's left to do is to unlock that directory so that Phobos can use it. And now if we list the directory, we can see that the file system status has changed to empty, which means that it's now ready to be used. but nothing has been written to it yet. And also you can see that now the physical space used and free are updated. The values that you see here are basically because that's using the file system that's on my machine. So you see it corresponds to the space available and used on my machine. Okay. And so now we should be able to write something. And there's only one thing that I need to do is to specify. So currently when you write data to Phobos, you have to specify on which technology you want to write the data. And by default, it's tapes. So I have to specify that I want to write data on a dir. And now, as you can see, the data is written to Phobos. And so if we list all the objects, we now have the object named OID in Phobos. I didn't put any metadata, so this is empty. I won't explain what this is since Sebastian will do it tomorrow. But this is linked to the versioning of objects. And we can also see how the extent relates to objects. So as I said earlier, an object can be composed on one or several extents. And so in this case, we know that the object is OID. So we have the corresponding extents here. You know on which media the object is stored. So in this case, it's a directory. So here we have a layout red one. It's not really, it's not a real red one since we only have one copy of the data. So here extend count refers to the total number of copies of the objects, not the number of replication of the objects. So it's a sort of fake red one layout. And here we have the path to the object on the media, which means that if I compare this to the original file, I should have the same thing. So this is how you know where the data is actually written. And here you can see the size of the file. So now I can obviously read the data and I can compare this and I don't have any metadata, but I could do something like this to get all the metadata. So I currently have nothing, but maybe I can it's not what I wanted to do. Right, so you have the metadata back. And you can also see that metadata here as well. So I think I showed you the basic commands. Maybe I can show you what the lock command does. So if I lock my directory and then I try to write an object, you see that the command fails because it didn't find any available media where to write the objects. Yes, so maybe I can take a few questions before I continue.
Yeah, we got some questions. I try to answer it as you do the demonstration. We got some persons who try to add the first files on devices, and so you need to, when you do the put, to mandatory indicate that you are trying to put on deals, so using the option family. And also do not forget to format and unlock the deal. Because if it's not unlocked, you will get a good no space error, meaning that there is no suitable device for your put. And also a small question from Pierre Emmanuel asking if all the IOs are handled by the Phobos daemon. And so I answered saying that the daemon only manages media allocations and the IOs are performed by the clients.
Okay. So we can now switch to tapes. I started with directories because even though that's not how you're supposed to use Phobos in production, it's much simpler to use. So for the tapes, we need to add we need drives and tapes, obviously. So for the drives, we need to know which drives are available on the system. So for that, this command will display all the SCSI drives, SCSI devices, sorry, on the system. And so as you can see, we have 8, I think, drives available. 4 of them are LTO5 drives, and 4 of them are LTO6 drive. We also have this medium X device, which is the entry point to the library. So that's the device Phobos will use to ask to ask the library to load a tape or load a library. Load or unload a tape, sorry. And those devices will be used by LTFS when writing or reading on the tapes. And one thing that's maybe interesting to say at this point is that if you look at the configuration, so the device, lib device is /dev/changer. And so if we look at this device, it's actually a symlink to SG9, and so that's the medium X device. So that's the connection to the library that you can use to query load and unload, to send load and unload queries, and also to ask for the state of the library. So what we can do is add one drive. So I think you won't be able to use this on the VM, unfortunately, but maybe tomorrow the VM will be fixed. So we can add, for example, SG1 here, and we can list all the drives. And so now we have So again, the drive by default is locked. It's of family tape. Each drive is associated to a node. So in this case, that's the name of my VM. So VM0. You can also retrieve the model and the serial number of the drive, and as well as the path to the SJ device. And so we can unlock that drive. So now that drive can be used by Phobos, and so we should be able to ask the daemon for the status. So you can see that this drive is now in use by Phobos and can be used by the daemon. And if I lock the drive, it's not used anymore by the daemon. So now I need.
Maybe you can ask. We have a question from Antoine. How does Phobos support offline tapes outside of library operator request?
So if you mean a tape that's imported, if you mean a tape that's imported in a library that's managed by Phobos, it depends on how the tape was written. So if that's a tape that was written by Phobos, we plan to have a feature that's basically the ability to import a tape that were written outside of Phobos. If the data layout is not known by Phobos, then it's a bit more complicated. So yeah, the plan is that at some point we will be able to import a tape that was written by Phobos somewhere else. Yeah, and I see that you are trying to use the tapes in the VM. So it's normal that the drive add works because it's basically just adding data to the database. But once you try to use it, it will basically not work, and the Phobos will put it to failed in the database because it's basically the drive does not exist, I think, on the VM. Sorry. Okay, so now we need to add a tape if we want to write something, and so for that we can use the mtx. We can actually use two commands. So mtx status is an old Linux command that gives you the state of the tape library. So you have data transfer elements, which are the drives. So I had 8 drives earlier, so they are here. And you have the storage elements, which represents the shelves on which the tapes are stored. And you have also the import-export elements, which are, I think, the address of where you can physically import tapes into the library. And you have also I don't know how they are called, but you have the arms that should be also there. And Phobos can also do basically the same thing as mtx. So you can do a Phobos lib scan, which will display the same information in a different manner. And so you can see here that we have the arm, so maybe and then all the tapes, the import-export elements, and the drives as well. And so now we can, for example, use this tape here, tape add. So I just have to put the name of the tape. I also need to specify which type of which technology of tape this is. So I can, so this is an LTO5 tape. And so now you will see the same thing as for DIRs. So we have, again, it is locked. You have the model, which is LTO5. Currently, you don't have any information about the volume, the amount of data you can write. You see now that it's an LTFS file system. And again, it is blank because it hasn't been formatted yet. So now we can format the tape as we did for the DIR. And we have to give it the name as well. So this is a bit longer because basically we are loading the tape. So since it's a virtual tape library, this operation is almost instant. But then we have to create the TFS file system on that tape. So it's a bit longer to do. And so if I now list my tape, I can see that it is now empty, which means that I can write data to it. And I can also store 1.4 terabytes of data. So obviously on my VM I can't, but that's the volume. And so now all I have to do is to unlock that tape. And I should be able to write data, except that I've already used this OID. And so I don't have to specify -f as I did earlier, because by default, Phobos will write on tape. So it's a bit longer. And what I can show you is the drive status. So as you can see now, I have one drive, the same as before, with that tape loaded. And I also have a mount path, which is the path to the LTFS file system. So if I list the LTFS mounted file systems, I can see that on SG1, I have this mount point, which corresponds to this mount point here. Yeah, and again, I can list the extent and so the last extent corresponds to the object I've just written. And so here I don't have the path as I did for the DIR, but I have the name of the tape. And here I have the path to the file in the LTFS namespace. So since I know that the tape is mounted here, SG1, I can do the same thing as I did earlier. And it's the same file. Obviously, when the tape is not loaded, I cannot read the data and compare it.
No new questions. Just I just send the links for the new VM. Maybe there is an issue about G Drive, just letting it some time to be uploaded. But no new questions.
Okay. So now what I can do maybe is show you a bit of the internals of Phobos. And what I had in mind for the practical, and that's something that you can actually do in the VM for the DIR. So basically, what I want to show you is some of the ways that you can connect some information in Phobos. And one thing that you cannot see without looking at the database is how Phobos manages the different resources at the when it's replicated on several nodes. Actually, I can show you some of this. So if you list all the information about a drive, you will see that there's a lock owner and a lock TS field. So the lock owner is set, it's very hard to read. Yeah, one thing I didn't show you is that you can select which fields of the table you want to display. And it's not owner that I wanted to lock host name. Right, so basically this is the, so we have a lock mechanism that helps us know when a tape or drive is used. So in this case, we know that this node is using the tape 0. And so if you look at the tape 0, you see that there is a lock owned by VM0, which is the name of my VM. And you also see that there's a lock owner that's actually the PID of the process that owns the tape. And so if I look for this PID, you'll see that it's actually the Phobos daemon that's that has put a lock on that tape because it's currently using this tape, which means that if I had another VM somewhere, I cannot access this tape because it's locked by this process. And the lock TS is simply the timestamp of when the lock was taken. Yeah, so yes, I can show you how we add the tape. So basically you need to know which tape you want. So you have two options. You can use Phobos sleep scan, which will list all of the elements inside the library. And so you can choose the name of the tape you want to add. In practice, you will probably import tapes, I don't know, 500 tapes, and then add all of them to Phobos at once. So then you would do Phobos tape add. You have to specify which technology. So this is an LTO5 tape, and then the name of the tape. And you can list. And now you can see that you have two tapes. One is locked, the one I have just added. And also what you can see maybe is that the tape 0 has been moved from the storage element 1 to the data transfer element 0. And also you can see that this index 0 here corresponds to the address that's here. So if you want to manually load or unload a tape, because there's some kind of error or something, some manual maintenance you have to do, you can find the correspondence between those elements and the other information. So there's a question about how the data is stored. So the data is stored directly on tape. We don't first copy it on disk and then on tapes. For that, we need to be able to migrate basically the data from disk to tape or the other way around. So for now, we can only write directly on tapes. And yeah, about the MTX status that returns empty slots, yes, that's the bug that we saw on the VM. So unfortunately, you can't use tapes on the VM. And one thing I can show as well is as for the dir, if I lock the tape, I cannot write data. So as you guys can see, I can't, even though I can't write data, even though I have a drive and the tape is loaded into that drive. Phobos refuses to use this tape since I have I've told Phobos that you cannot use this tape.
So we have some questions. Pierre-Emmanuel asks if we manually dismount a tape reported as mounted by Phobos, is it detected?
So I think if so there's a few things. If the LTFS file system is mounted, I think you can't unload the tape. You have to first unmount LTFS to then unload the tape. But if LTFS is not mounted, you can unload the tape manually. And this is not, I think, well supported by Phobos, because internally, if it will query the state of the drive, but if you change the state, it will not, depending on when you change the state, it will not necessarily see it. And so if you want to manually dismount a tape, you need to stop the daemon, basically. And if you restart it, then it will see that the tape is not there anymore. And it will,
Yeah, we had this kind of issue like 4 or 5 months ago when we have some corruptions happening on tapes because there was some locks that were not unlocked, and we forced dismount the tape. And what was going that as Guillaume said, we needed to restart the daemon just to have a new lookup, and it will then see that the tape is not mounted anymore. That's things that can happen. Also, another question from Dusan. Can we migrate data in multiple copies to different tapes for higher data protection?
yes, you can. Maybe I can spoil a little bit of the tomorrow's presentation.
Okay, you can.
You can actually, so the default layout is the red one layout, but by default it writes only one copy. But you can ask, for example, 2 or let's say 3 copies of the data, and it will not work because I've locked the tape. And so I need to unlock both tapes if I want it to work. And I think I also have to format this one.
Replicant to
yeah,
2, I think.
I only, yeah, and no, the issue is that I only have one drive, so it won't work anyway.
Also, yeah.
I need 2 drives, SG2. And so basically I'm asking Phobos to write 2 copies of the object, but you'll see this in details tomorrow. And if I list the extents, you can see that for where is the OID? Here, the last OID I've written, COID2, you have basically 2 copies of the data on 2 different tapes. Yeah. Okay, so the new VM seems to work.
Maybe not for everyone, but I don't know. If Stefan, did you use the VDI link or the OVA?
I use the OVA on VirtualBox 6.1.
Okay.
The only thing I had to change is the USB driver. I had to downgrade it to USB 1, but that's all.
Okay. I tried both on VirtualBox and both works. So don't know. Maybe yeah. If the OVA works for you, so the upload works also. Okay. Thanks, Stefan.
Well, I'm still having a problem with the OVA. I tried to open it in VMware Fusion, and it keeps giving me those errors.
Okay, maybe I can try to look and find why you have those errors, but not a VM expert. Okay.
Okay, so I mean, I've basically showed you what I had to show. So if you have maybe questions or
Guillaume, could you show again the commands you used to import the tape?
sorry, to what?
The commands to add the tape. There was no, while we were getting the new VM, I didn't get those.
Okay, so so when you want to add a tape, you need to know which tape you want to add. So you have 2 commands that you can use. There's empty status. So this command will display the every element that are on the library. So as you can see, I have the data transfer element, which is the drive. This one has a tape 1 loaded, and this one has tape 0 loaded. I have the storage elements, which are the shelves on which the tapes are stored. And so you can see all the tapes that I have in the library. We have the same command, but that displays information a bit differently. That's Phobos sleep scan. And so, for example, if I want to add the tape 2, I add the tape. I have to specify the type of tape I want to add. So in this case, it's an LTO5 tape. And so once this is done, the tape is in the database. Sorry. So you can see that it was the tape 2 that's now in the database. And if I want to use that tape, maybe one interesting thing to see is that I currently have tape 1 and 0 loaded. And if I format the tape, now the tape 2 is loaded. So you switched the tape 1 he removed the tape 1 and loaded tape 2 to format it. And now it should be empty, which means that you can write data to it. And also, since I wrote something on the other tapes, you can see that on the statistics, I have 2 objects on tape 0, 1 on tape 1, and I have currently nothing on tape 2 that I've just formatted. So it's still in the state empty, but the 2 other tapes are in the state used, which means that some objects have been written to it. And once a tape is full, the state is full. And also, when one thing that some of you have seen in the broken VM is that when Phobos encounters an error on a tape or even on a drive, instead of locked or unlocked, you will see failed, which means that the Phobos saw an error on that resource and basically removed it from the set of resources that it can use. So there's a question. Say you want to take a drive offline for service. You would just lock the drive with Phobos. What if it's in use with the current operations? Okay. So if you lock a drive, basically the client command that so the Phobos drive lock command will send a request to the send a request to the daemon and ask it to stop using that drive as long as there is an IO, so a read or a write or even a format on that drive. The lock command will block, and then once the drive has finished the current IO, it will be released, and the client command will give you back will finish basically. So yes, the current operations will be finished if you lock a drive.
Cool, thanks.
So for the maximum number of objects managed by a single Phobos system, currently the only system we have manages, I think it's a bit less than 300,000 objects, and it doesn't show any sort of limitations. We haven't tried to see what the limit of the. I mean, to my knowledge, we haven't tested the limit of Postgres. So I don't have numbers on the maximum number of objects. Yeah. I think there's a question for you, Sebastian.
Yeah. And so it's answered. The script is located in USA has been. So I think you have directly accessed by calling the script name. As this is in your path normally. And so the script, for those who ask, does two things. The first one is to set up the virtual tape library. So for this, it needs a non-negligible space. I think it will set up like 8 gigabytes of space for the tapes, and also call the initialization of some fake databases that we will use tomorrow for the advanced exercises, where some of them try to see strange examples of what can happen on a DB and try to analyze it and solve it. So that's what we will do tomorrow. So for the VM, as I said in the chat, the last thing I can do, and I try to have this available soon, is to give you the OVA with a 1.0 format, just to see if it changes things. But in case not, sorry, I do not think I can do anything else.
Yes, and maybe to expand a bit on some of the features that I don't think Sebastian will cover tomorrow. So as I showed you in the slides, you can have additional queries to the list commands. So you have for every command and subcommand of Phobos, you have a dash help option to display all the information. So for example, one interesting thing about the extent list command is that you can specify a name. And for example, I can say tape 0, and I can also select which column I want to output. So for example, by default, it's the OID. So this command will basically display all the objects that are stored in this tape. And so it can be useful if you lose a tape, or if, I don't know, some tape is corrupted or something, you can quickly list all the objects that are affected by the loss of one tape, for example. And so you can try, if you have the VM working, you can try to see the different list commands, what you can do. So as I showed earlier, you can filter using metadata. I won't show you the deprecated because I think Sebastian does it tomorrow. And for the extent list, you have an option degroup, which will basically display every extent as a single line. So if we look at yes, it was TOID2, which was written with a REPL count of 2. So now you can see that it's in two different line rows, sorry, of the table. So you know that this this object here is written on this tape here.
Okay, so do we have other questions for today? So Antoine said, I don't see an option in Phobos.conf to specify where else the demo client can contact the LRS.
So I think I said it earlier, but the daemon, the Phobos client is local to the daemon, so you can't execute a Phobos put command. You can only execute a Phobos put command on the node where the daemon is running, where a daemon is running. And so we only use a local, a Unix socket to communicate with the daemon. And by default, it's there, so I should have so that's the socket used by the client.
Yes, daemon is LRS. This is a bad naming, but at first, in the first versions of Phobos, LRS stands for local resource scheduling, meaning the modules that will manage the scheduling of all the resources access. And so in the 1.91 or 92, 1.90, we externalize this behavior in a daemon service. And so now I think we may need to change all the naming to remove the LRS presence, but yeah, LRS is the daemon.
And for so Phobos is not a single node in a sense that you can have as many daemon as you want working on different nodes, but then you need a layer above Phobos that will dispatch the requests to the Phobos nodes. But you will see that tomorrow.
So today we will present the advanced part of Phobos, which deals with two subparts. Mainly, the first one is talking about how to distribute a Phobos system amongst several nodes. And the second subpart will talk about advanced commands. We saw some of them or some first options yesterday, but we will dig that more in details today. Okay. And as I said in the chat, the first VM link you got from Karina also is good enough for today, as we will not deal with tapes. So let's start. So to deal with the distributed system Phobos, the first thing we did is to have a service, daemon, that will be available to run and so do receive the request from the clients. And so the things was to know if we need to manage the allocation of IOs, manage the IOs, or other things. And what we decided is to have the daemon only manage the allocations, which means you have here as a small design that help you understand what the daemon do. So we have a user that want to put an object in Phobos. And so we will call the Phobos put command line you saw yesterday. The Phobos put is directly taken into consideration by the client, which do not know on which tape or which directory it can do its I/O, but it will ask the daemon by a request. Yeah, I need to put an object that is, we'll say, 1 GB. And so, do you have a medium that is available for 1 GB? Also, I need to have this object on tapes. So the daemon will take the request and search in its in the database and also in its local memory if there is a tape that is available, and if possible, if the tape is already mounted, if a tape already mounted have enough space to to have the object written on it. Once he decided on the tape, he will reply the client and also lock the tape and say it is reserved for this client. And so the client will get the reply, get the path to write the object, because our LTFS backend is quite the same as the POSIX backend. It will do some write and read operation. The difference is among the synchronization on tapes. And so we'll do the writing I/O directly on the file system that was mounted. So the daemon here will not do any I/O. It only reserves media. And on a single node, all the requests are centralized on the daemon node, on the daemon server, to schedule all the requests in an optimized way if possible. So also, as yesterday, if you have any questions, feel free to ask it in the chat. If I do not see them, Guillaume will ask me the questions. So now we saw how a daemon and a client interfaces one with the other. The goal is to now define what a Phobos node or Phobos server is composed of. So you still recognize the client and daemon here. We have the client that receive a request from a user, or here a copy tool, and do the request reply system with the daemon to do the I/O then. So we have here the three main components of the node, of the Phobos node: the client, the daemon, and the copy tool. The copy tool which replace the user that we saw on the previous slide. And the copy tool will receive requests from the network to say that on this node, I need to push an object in the Phobos system. And it mainly consists in a tool or script that receives I/O request and then call Phobos Client API or Phobos CLI. So then we can see the first step of Phobos distribution amongst multiple servers. The only restriction we have is we need to have a common database between all the nodes. So here you still see on the picture the distributed key value database, which is connected to all the servers. Here are the three. So the I/O distribution needs to rely on a feature to know from to which node I need to direct the I/O, to know which Phobos servers is the right one. So here we have the S3 clients that got a lot of requests to send to the Phobos system. And the S3 client will attempt a locate command to know if he need to direct the request to the first node, the second, or the third node. The database will say, okay, you can try to the second node. So he will send the request to the second node here, and the S3 server in there, so it can be the copy tools and the Phobos daemon, will say, oh no, in fact, it was not the right one. I will redirect it to you to send it to this third node. Okay. So this is a mode that can happen if you don't have the locate feature in the S3 client, meaning if the S3 clients are not connected to the database, but also can be in the future something that will be used to redirect request in case the context changed. Maybe because when we do the first locate, a tape was not used by any server, and once the request reaches the second server, well, the tape was moved into another one. We will see in the second part when dealing with the locate feature that we try to avoid this kind of behavior, and we see how. Yeah, so that's all we got here. Okay. So another example with Lustre HSM. As I said, we got the Lustre HSM here that got some requests about restore and archive files. So the coordinator will talk with the Phobos coordinate tool application here that got access to the locate API. We'll communicate with the DSS to know if there is a good host, a good server for the request for the restore request. Okay, so it will give the object location. The Phobos coordinate tool will then direct its request to the right copy tool. We have one copy tool in each Phobos node. And then here we'll say, okay, it's copy tool 1. So I will get the request. We'll inform the daemon that we need to retrieve one object which is on tape. So the daemon will mount the tape on its on the drive in the drive, and then have the file system available to retrieve the contents of the file, then sending the file to the Lustre file system. Okay, so the same application, we have the same kind of communications as we are in S3 or in a Lustre HSM system. So then for the S3 server, we can imagine having the object store having an S3 front end. Okay, so for this we have in IOC the tool Demos that is developed by iCheck, which have this role of being a front end for Phobos, and so receive requests, S3 requests from different clients, clusters, workstation, or remote access, and try to be really efficient on and really scalable to gather the request and then send them to the object store. Because Phobos is an high performance and scalable storage tool that can manage a wide variety of high capacity storage as tape libraries, and provides also an easy uniform management of the storage resources. So here we have demos, but we can imagine any protocol, any tool that use Phobos Object Store as backend, and then using any protocol in front end to retrieve, put and get requests. On our file system, and in production this year, we use the Lustre parallel file system as the main file system for hot data and information that are not archived yet. And we use, since this year, in one of our computation center, Phobos as a backend object store. And so we communicate, as shown in the previous slide, through the Phobos LHSM copy tool application to retrieve the restore and archive request from Lustre and send them to Phobos to put and get the right objects. We do not have yet performance metrics on this installation. It's really at its debut. I think we have our first objects pushed pushed a few weeks ago or will be pushed soon. So no metrics yet, but once we have some data, we'll be pleased to share them with you. Can you describe the number of daemon, drive, and luster nodes? I don't have the configuration in head. Maybe Guillaume, you have it.
I don't know if we can share this
Ah,
information. So.
Has this yet? Okay. Okay. But this is used as a distributed system. Okay. All right. Do we have any other questions? Or can I go through the second part? Of the presentation, which will be a little more describing. Oh, yes. Okay. So now talking about different advanced commands. The first one is about resource tuning. So the goal here is we may have a lot of tapes and we want to distinguish them. So the first thing we can do is to tag them, to set some tags on them. So here we have a way to put some tags on the tape. Phobos tape update, -- tags project 1 class B, meaning that all the tapes that are referenced here from the 0 to the 99, so 100 tapes of LA technologies, will be tagged as project 1 and class B. This command, we will see it later during the exercises, but can be used to clear the tags of tapes or also add other ones. So then we may push data to specific resources. So here, pushing data to any medium with tag class B, when using the put call, having the -- tags option, specifying class B tag to push the file pass to file as object ID 1 in tapes that are tagged class B. And we can push data to media that have both tags, project 1 and class B, using a comma to separate the different tags. Is there a kind of authentication mechanism on the client to access to Phobos daemon or to objects stored? No, we do not have this because the client and the daemon are really far from the intervention of a user. They are in a different class of servers. It cannot be directly reached. So the authentication mechanism are upper than them. I don't think this is in our roadmap to add this kind of feature in Phobos. Am I right, Guillaume?
Yes, the idea is that since Phobos is can only be accessed through a front end, it's the role of the front end to do the authentication if necessary.
Yeah. Okay. So for now with tags, we can easily get the intersection of both tags. Okay, tag A, tag B, project 1, class B. We cannot have, for now, the union of both tags, meaning I don't care if it's only project 1 or class B or both, but give me one. Maybe if we have some desire for such a feature, we will develop it, but that's not on our roadmap yet. So the next way to tune our resources is to set permissions, to set a mod access. So here we have a first command, Phobos tape set access, to say that the first 10 tapes of our pool can be put, meaning that we can put an object on the tape, get to retrieve data, and delete to we will then say in a few slides to soft delete the objects on those tapes. But we can also revoke accesses. We need the double dash, so don't forget if you use it, to remove the put access from the 90 other tapes. Of course, we can check the permission of all tapes using Phobos tape list and checking the put access, get access, and delete access attributes of each tape. So here we can see that we have our 10 tapes that have true for all the accesses, and the 90 others have false as put access. So we cannot put new objects on those tapes. We can only retrieve some from them. So that will help manage the different pool of tapes you got. For instance, if you only want to put objects on unused tapes or tapes of a new generation, that's a way to deal with this kind of request here. Okay. So if the permissions are logic or if the permission is written on the tape. No, it's not written on the tape. It's only logic, meaning it will be given to the database. So we will have on our database for the tape information parameters that says that it does not accept any put. Okay, so the goal here is to say that if a tape is on a Phobos system, normally you will only access the contents of the tape using Phobos. So we only prevent the put access from a Phobos API. Meaning if you have then a Phobos put and you have a tag that specifically say you need to have the object on the 073000 L8 tape, okay, the put will fail. Because no, not the 0, but the 10, the 10 here. The put will fail because you cannot put new objects on this tape, okay? And this is the same thing if you have an object on one of the tape and the get access is not possible, you will not get those objects using Phobos. And we do not consider that you can that you will access the information on the tape in other ways than using Phobos. So this is only a logic permission. Okay. So then something that was a little bit spoiled yesterday. We can have multiple arguments with put, and the first one are to specify a family or a layout. So we have Phobos put -- family tape to put file to put as object ID in the Phobos system. And so this is to specify that we want to have this object in the tape family. So for now, we have only 3 families in Phobos: tapes, directories, and Rados pools. And the default family, if you do not give this argument, is tape 1. And you can also use a layout. So here we only have the red one layout, but we can still specify the replicate count. Here, replicate does not mean how many copies other than the original will be written, but including the original. That means here for REPL count of 2, we will have the original and a copy. So both replicates of the objects on the tapes. File to put object ID. So this the replicate count is tunable. You can have 1, you can have 3, 4 as you wish. The red one, we only have the red one layout available for now. In our roadmap, we have the erasure coding mechanism that will be worked on this year or next year. Okay, so now we can go with aliases configuration. So the goal here is to facilitate the life of operators by sending to users or oblige users to use an alias. And an alias will allow someone to set, with the example here, if I need a simple alias, it means that I will write my objects on tapes using the red one layout with a REPL count of 1 and only on tapes that are tagged foo tag. Okay, meaning that the whole command line with which tags, which family, which layout params is reduced to having a simple, and we will see in the next slide, -- alias simple option. Okay, so for now with aliases, you can set target family, target media tags, and data layout and its parameters. And if we observe that we need other parameters to be in the alias, so we will add it. And so I don't know. See, yes, here the example is a part of the configuration file. We will see it in one of our exercises as we will add a new aliases. So you only need to copy this part and add it on your configuration file, reload the Phobos daemon, and then you will be able to use the alias to put objects on your Phobos system. And so then, as I told before, if you need to say that, okay, we have some guys that are working on with biogenes, okay, biologic genes, and need to archive their data in specific tapes with a specific layout, then you can redirect the Phobos code commands then they will use or wrapping it by having an alias of, okay, for the biologist, meaning this is on tape with thread 1, REPL count of 2, and something like that. So then, how to put using alias? As I said, Phobos put -- alias, simple, the name of the alias, and we have the file and the object ID. So this is quite of simple and better looking command than the previous ones. And also we can put metadata on our objects. For instance, here using the dash metadata option, I can set some metadata values, like dataset value is set to test and value is set to 42. Those metadata will be registered in the database, as you can see here with the object listing, and also in the tapes along the data. Meaning, if one day the database is corrupted, we can still retrieve the metadata information of each object by reading the tape. Okay, it will be really long to retrieve all the metadata, but at least you can do it. So then to list all metadata of objects, you can use the Phobos object list and outputting the user MD field here. So for object ID 1, we got no metadata, and for the object ID 2, as seen before, we have 42 for value and test for dataset. And obviously, you are not limited to 2 metadata. You can add any as you wish. I don't think we have a limitation on this, but we did not test it really really high. Also, if you need to filter the objects using their metadata, this is possible. With the object list, you can use the dash metadata option to say, I only want to see objects that have as metadata and dataset value test. Meaning only object ID 2 will be returned here. Yeah, aliases are not stored in Phobos dconf for now. We have a way to store default aliases in the source code, and if configuration information will be in the database, then in the database, but that's not desired yet, as we do not want to force the operators and administrators to have default aliases. We let them define the ones they want. Okay. For the metadata, this is something different, as this is only metadata retrieved from users when they push their data, or maybe by applications encountered through the whole process of archiving data. Sorry. We can imagine having the Lustre file system that will define some information as what we'll have from Lustre. We got the maybe
We store the layout of the file, for example.
Yes, layout for the file, but if we yeah, okay, for the archive it's okay. So the layout of the file will be stored as a user metadata because this is filled by Lustre. And then when we'll have the call for Phobos object, Phobos put, we'll add dash metadata, Lustre underscore layout, and then give the actual layout of the file on the Lustre file system. Okay. And this is registered in the database and in the tapes or the media where the objects are written. Yes, Stefan, you can use any Lustre information you want. No issues on that. It depends on the copy tool. I think for us, this is the copy tool goal to give the right information on the as metadata, as user metadata. So for player manual, can many Phobos clients run in the same time on the node? Yeah, you can. You can. So here we have a copy tool that can retrieve multiple requests and then call one client for each request. The Phobos daemon node is capable to retrieve multiple requests at the same time. And in fact, this is important to do a better optimization, better scheduling. So the goal is to retrieve multiple requests to see if it can group some requests together. Maybe we need to read multiple objects that are on the same tape, meaning we only need to load one tape, mount it, and then grant the access to the tape to retrieve the objects for each client that needed it. Okay, and maybe we can have some puts that can be made together by also having one tape or two tapes if we need to have some replications. Okay, but yeah, you have multiple clients run in the same time on the same node. Yeah, that's the goal. And how do you throttle I/O on the same tape? So for this, for now, we only grant the access for one tape in a sequential way. Meaning if both clients need to access the same tape or will access the same tape, we will grant the access for the first one and then the second one. Okay. But the goal with tapes is not mainly to parallelize IOs, but is to avoid doing multiple synchronizations. In this example, if we have 10 clients that are trying to write on the same tape, that will write on the same tape, we'll not do a synchronization with the tape each time writing is done, okay? We will wait some time, wait some requests, maybe wait that than waiting for 10 gigabytes to be written on the tape. And once a batch of requests is done with the writing, we will do a sole synchronization, meaning that we will economize some time here because the synchronization step is a longer step in the IO process of tapes. Yeah, that's right. We let LTFS buffers work on that.
Actually, LTFS is quite bad at handling
This is the buffer serialization.
write operations. There's they worked on an IO scheduler that buffers the writes. So if you use LTFS to write, you write using several processes to the same tape, to the same LTFS file system. The files will actually be fragmented in small portions, and when you want to read that again, it will be very, very slow. So in Phobos, we don't do that, and we, as Sebastian said, we write one object at a time on tapes.
Yeah, but all writing will be serialized in the buffers and then synchronized on the tape. So then Stefan asks, is there a way to list active pending requests to a specific tape with Phobos? I don't think we have, but with the Phobos status, we can see if a tape is used, right?
Yes, you can see if there is an IO, a pending IO, but you can't see
which one.
All the requests that are pending.
Okay. I think this is something we already discussed in the dev team, and maybe something we want to have in the future with the stats. For example, we know that for the scheduling, getting the number of requests that are waiting, this kind of numbers are important to do some optimizations on the scheduling. And maybe we can try to have those information render available through a command. That's something we discussed. We are not sure we'll do that, but that's something in our minds. And yes, you saw yesterday the driver status command. Yeah. Okay. So we can continue. So then we have the versioning, which means we tend to have multiple versions of one object in our Phobos system. So at first, Phobos has a simple rule that said an object is unique, meaning when you do a Phobos put command with an ID that is already known by Phobos, the command will fail. But you can have a newer version of the object if you use the -- override command. And in this case, object ID will not be replaced, but we will add a new version of the object. We have a pseudo hidden field that is called version that is incremented as the object is updated. And the oldest object, the one that is overwritten, will be sent in another table called deprecated. And so all the old versions of an object, meaning all the versions that are not the alive versions, the most recent ones, will be considered deprecated. So for now, deprecated, it only means that the object is still present on tapes, but at some time, it can be removed. Okay, so this is kind of the deprecated state is a soft remove object, not a hard remove one. So soft remove state. Sorry. We can list the object versions, different one, using Phobos object list -- deprecated object ID. So we will have all the past versions, not the alive one. And we can retrieve an old version of an object using the -- version and the number of the version when doing a get. Okay. But that's not all. We can also delete an object, which means here a soft delete. The ID will be available for a new object, not just a newer version, but if we don't care about object ID anymore, all the versions of this object will be deprecated, and we can put a new object, which has nothing in common with the previous one, as object ID. In case we have make the mistake and we need to retrieve the object ID we just deleted, we can obviously handle it, precising that this is a no ID object ID. Why? Because in fact, every object that you submit to Phobos will be have a UUID, a universal uniform identifier. So here it's a dummy UID, ABC12312, okay? And each object and all its versions will have the same UUID. But if you delete one, in this case, the next put will get a new UUID that is not known from the Phobos system, okay? And so you can also handle objects using UUID. That's why we precise here if we want to know ID or UUID. Okay. We can list the deleted versions as in the previous slide with deprecated version. We can list the delete objects here. What object is -- deprecated object ID? Sorry. So the difference here will be that the UID will not be the same as the one for the live object, okay? And also, if we cannot handle an object, or if the version we want is not the most recent one, we can still retrieve them using Phobos get, precising the UID, and or precising the version of the object. And it misses here the location of the object in the system. Okay, and so this is important to see that as a soft remove, because we have on our roadmap, and this was told yesterday, features that are bound to the media life management, and we want in that to have the possibility to repack tapes. Meaning, if a tape have like saying 80% of its capacity that is dedicated to deprecated objects, what we want is to retrieve the alive objects and put them in another tape and repack the tape. Okay, and for that, what we plan is having in the configuration file different deprecation policies. Maybe saying that a version that is deprecated since 2 months can be removed, can be repacked. Maybe a version that is 5 versions away from the most recent one can be repacked. Some policies like that, okay, something that is really configurable and tunable. And the goal is to define multiple policies to have the best garbage collection mechanisms. Then we'll have the last slide of this presentation, so quite right on time, talking about object locations, as we already said during the presentation of Phobos distribution. So we can locate an object. Phobos locate object ID will return back the host you can use to do your get command. In case there is multiple choices, you can propose a suggestion using the -- focus host and then the host name that you wish to retrieve it. So if host name is also a best choice, host name will be chosen and not another one. This is important in case of the coordinate tool with Lustre or what you want if you're using F3 or other frontend, because it allows the coordinate tool to really precisely handle the sharing of requests. Meaning, it will say, okay, I know that one of my node is low loaded, so I want to send the request to it. But for that, I need to be sure that the locate is possible. So I can use Phobos locate, focusing this host in particular, and if it gives me back this host, I just need to send the locate to it. Okay, so that's why we have this kind of feature here. Also, what we can try is launching a Phobos get, but specifying if I'm the best host, do the get. If not, send me an error saying that I need to go to this host to do the get. So this is to avoid having like, okay, I can retrieve the information on tapes you desired, but for that I need to say the other host to release the tape, giving it to me, and then loading it, mounting it, which is quite time costing, okay? And so we can say with this one, if this is too long, if this needs to communicate with me, don't do that. Just say to me which node I need to contact to do my get, and I will get it. And at last, we can also do some locates on tapes and dirs, but directories. This is not really important, but on tapes, just to see if a tape is mounted or not. So here, it can say that 073002L8 is already mounted on host 2, so let's go to host 2 to have some information on the tape. So that concludes the first part of today's session. If you have any question. Those Phobos manage tape drives shared on FC Fabric over many hosts. No, the policy in Phobos for shared tape drives if we do not access them. For us, a device, and so a tape drive, is something that is owned only by one host at the moment. We know that we may have some shared devices, and so we need to take this into consideration, like, for instance, NFS system. In this case, we have some drives and some access that are shared between hosts, but we do not have those features in Phobos yet. We are thinking about that. Okay, so if there is no other question, I think we can go on a break.
Yes, we will have now 15 minutes break, so we will reconvene at 15:05.
Yeah.
Enjoy your coffee.
Yeah, same, thanks. Okay, so that means break is over and we can continue. So I will share my shell. Okay, can you see it? Is it big enough? Yeah.
A little bigger would be nice.
Little bigger. Okay.
Good. Thanks.
All right. So I think the goal for that is we will go through each exercises quietly together. Maybe before going through an exercise, letting you read the contents and try to find some items yourself, and then correct it all together. Okay. So for that, you normally have one VM. So if it's the first link we send it to you, you only need to change the name of the host name. So I think this is something like that. As VM0 here. Okay, so there is only one dash. Oh, what? Okay, just checking that. Ah, all right. There is no dash at all. Of course. Up. Okay. And if you are on one of the new VMs we sent on the chat yesterday afternoon, normally you already do that, but be sure to run the script setup training as sudo. Okay. So basically, we have two script on this setup training. The first one is to set up the virtual tape library. So meaning we will have 8 drives, I think, and something like 20 or 24 tapes that are available. For the exercises today, tapes are not used, so that's why you can only use the first VM. And then we will have another script to set up the databases we will use during this session for each exercise. And how we will manage this? So, I switch to sudo. Okay. We will go through all databases by modifying the configuration file. And for instance, for the first exercise, it says to change the DB name to Phobos 21. Okay. So depending on which exercise we will work on, we will need to start the daemon or to stop it or to restart. Okay. So for this one, we will need to start it. Okay. Normally everything is okay. Can double check that. All right. This is running. Okay. Maybe the daemon will not start. In this case, this is because you badly modify the config file and the DB name. That may be a case. Okay. So the first exercises will be about labeling media. And so we will create a set of directories, then push them to Phobos, and trying to put some items using tags. Okay. So I will just let some seconds, some minutes away. If you have any questions about what we saw just before the break, or about the first exercise, don't hesitate. And I will easily go through the exercise in the other case. So first point is to create a set of 10 directories. Here we are. Then giving for some of them, for both, you had one tags cache. The first one, for example. Oh yeah, of course. Right. Oh, we only have the first one? Ah, yeah, that's my bad. Okay. I did not start with 0. Okay, so tutor1 and tutor2 tagged as cache. We can add 2, 3 to 5, 4, 6 to 10, tag them as archive. What's wrong here? Yeah. Okay, we'll do survey here. We don't want to. Okay. Oh, that's because I got 2 characters. That's why. Okay, that's my bad. I could have done 6 to 9, but having 10 then. That's how cluster shell works. Then what we know is we have archive for the last 5. So I can do an update tags archive for 6 to 9 and n. Yes. And then doing read only on 9 and 10. Okay. Then we need to format all the directories. Okay. And once that's done, to unlock some of them. Here we are. Okay, so those are simple commands as we did some of them yesterday already. Okay. Then we can try to launch the following commands. Okay, that will not work by simply copying them. So up, back. I will put etcs to tutor1. Yeah. Of course, it does not work because we did not set the family of the command. So this one works. We can then try the second one, adding the family for cache. It also works, and it works because if I list, I can say the name, garden status, virgule, and text. Okay. We wanted, so at first we wanted a put on any directory and any is available, as we have 3 directories that are unlocked. We then wanted to have one for cache, and we have at least 1 directory with cache tag that is available here. And what I see is 9 and 10 are badly renamed. Okay. Because when you do the update of tags, it will erase the previous tags and replace it with what you suggest. So I need to have both. Yeah, that's right. Okay. All right. So then I can try the third line. Asking for an archive directory, and we have one with 227. Then I can ask for the read-only tag. And what he said is there is no such space left. And because the read-only tapes or directories are both locked, so we cannot access them. And if we had not only read-only but also archive, we will have the same issue because, as I said in the presentation, this is not a union of tags, only the intersection. So we need to have both tags available on the medium. So it also failed. But as suggested by the other point, if we unlock the nins directory, it means we can put objects. Oops, 225. Okay. All right. Is it clear for everyone? So yes, that's how you manage tags for media, how you can update them, or you can then put objects on them if the directories or tapes with requested tags are available or not. Okay. Then we will play a small bit. With labels. So, modifying the configuration. And here we can restart the demo. Okay. So here are factice tapes, dummy tapes. So do not try to do any put on them. Okay. We only need the daemon here to see. Did we need the daemon? I think we didn't need the daemon. So this will work without it. We will try. Okay. So the first task is to list the available tapes. Tape list. So we have a lot of them. We can try an output hole, but I think the output will be helpful. Yeah. But we may need to want here. I think at the end status no, we will have which one? Tags, model, and name, maybe. Yeah. Okay. Name, model, tags. Ah, that's better. Okay. So as you can see, we have a total of 16 tapes here on both LTO7 and LTO8 technologies. Okay. And some of them are corrupted. Okay. And the goal of the exercise is to update the tags, such as LTO7 tapes are tagged as old gen, and corrupted tagged tapes are tagged as to format. And then we'll check if the update worked. So what we can do at first, we can try to retag the corrupted tapes. So for that, you have option of Phobos tape list minus upper T or dash tags to filter on tags, meaning that we can do a Phobos tape list T corrupted and got the tapes that are directly corrupted, and so we can then give them to an exarg in Phobos tape updates. Format. For the other ones, that will be a bit tricky. As we do not have a way to filter according to the model. Maybe it's a feature we will need to add. We'll discuss about that. But you can still do the modification, retrieving the name in the model, CSV format to have for one line, one name and one model separated by a comma. We can then grep on LTO7, get the result, and giving that through 6 hours of Phobos table dates. And as shown on the previous exercise, the corrupted tapes, the corrupted LTO7 tapes that were marked as two formats, so the 3 and the 4th, 3rd and the 4th, the tag to format was overwritten to indicate all gen now. So we need to fix that, as this is not what we wanted. To update the all gen, but also to format the corrupted. Yeah, that's better. It's okay for everyone. You succeed in trying the exercises on your side. So we'll go to the next one. Find configuration. Here also we don't need to set up the daemon. And so this is about updating accesses. So we can at first list the directory. Oops. The other way. Okay. Maybe I want better information, like put access, get access, and delete access. Yeah, that's right. Okay. Everything is tagged as false. So our goal is we want to write on the directory that is tagged fast. So for that, we need to get another information for each of our directories, which is tags. And so we know which tag is fast. So we can directly take the MNT 23 towers, or we can also use the list minus uppercase T fast to retrieve that. Those the set access SP as we want to write it, so we want to put objects on it. Let's do. Okay, so here, if I do the Phobos list, okay, we have as wanted put access set as true for Taurus. So then we want to retrieve the object tutor1. So like that, I think there is an object list tutor1. Okay, if I do a dash also, as we said, we got the UID, we got the version. Okay, so this is the live object. The UID was set for this one, and there was no overreading for this object. This is the first version, but with this command, we do not have information on which directory the object is located. So we will need to find it using the extent list command. The extent list command says that this is the location, the physical address of in the path in the file system here. The number of extents we have only one on directory and one, and we have here the media. So this is Gemini. So the object with tutor1, Gemini, we need to have retrieve access only. So Phobos dir access plus G for get. Yeah. Okay. All right. And retrieve the object tutor1. And what we want for tutor2 is to delete the object. So same way to access things. We will check the extent list for tutor2. We will see that it's also only one extent on Arias this time. And so set the access plus D for delete. Okay, and then listing the directories. That's done. So it means that I think we can try. If I start Phobos D, I want to push an object up here. Succeeded. Normally it is written on Taurus. Yes, that's right. Okay. But what it means also is we can retrieve one, sorry. Yeah, that works. But we cannot retrieve tutor2 or tutor3. Operation not permitted. Okay. About the deletion, I think, if I remember well, that this is only for the hard deletion mode, no? Guillaume, if you're the answer for that.
I think it's just for Phobos there.
I think so. So that means I cannot Phobos there like tutor1. Right? But it works.
Okay.
I think this is for the hard delete.
Okay. Yeah, maybe
Once,
it's not.
yeah. I think the feature is not available yet, but it will be. So we could not. We will not be able to delete tutor1 from the directory because the access is not available. And as or delete, so maybe we'll need to do some of rebranding of the field here or the command, but this is for hard delete and not a soft one here. That's what I think. Okay. So then I will retrieve that. Okay. And for the last question, if you want to remove all the accessive of the directories, we can do Phobos there. Set access dash gd. And go back from the beginning. Okay. Everything is okay for now? No questions? Y2 for the last command. Y2. Yeah, okay. Because this is, I think, the way argparse in Python work. No, maybe just how the command line works. This is to avoid minus PGD to be passed as an option, because this is a mandatory information of the command. If you go through the help, okay, this is a positional argument, the flags, and so this is just to say that the information that are after the double dash are for positional arguments. Okay, if we do not have the double dash, it will be considered as an option, and in our argparse section here will be categorized as a bad optional argument, and so we will have an error. So that's why. If you have mandatory arguments, positional arguments that starts with a dash, you need to separate them from being passed as an option. That's why. Okay. Yeah. So for this one, do not start the daemon, because this is a fake database with some logs on resources that are dummy taken, and if you run the daemon, the logs will be removed from the database as cleaning procedures, and you will not be able to solve the exercise. Okay. So the first command asked is to list the available tapes and directories. So we can do something like that. What kind of information do we want from them? I don't think we need ones. We also have for there the same things. Okay. So we have 3 tapes and 3 directories to locate. So for that, we can go through Phobos tape locate P00L7. And here we have the VM0. So that normally means that the tape is reserved by us. Okay, meaning the host locked the tape for itself and got it loaded and mounted in a drive. And for that, we can check, I think this will work. Yeah. What we know here, if we list information of the P00L7, we got a lock here, lock timestamp that was set. And if we check the localhost name, it's us. In Phobos daemon, that means that the tape was loaded and mounted and is currently in a drive. This is a fake database, so it's not the case, but that simulated this behavior. We can then locate the first tape and say it's VM1. So it's seamlessly means the same thing, that the other tape is used by VM1 hostname, so we can check on that. And that's the case. VM1 has localhost name and the log timestamp here. And if we try to locate the last tape, we got nothing, which means that the tape is currently in the library and is not loaded. We can check that, and that's the case. We do not have one that got the lock on it and no timestamp. Okay, that means if you do a Phobos drive status on VM0, do not do that because the daemon is not online, so it will not work. But if this is it was a reflect on of some things of a real experiment, we will have, when doing a drive status on VM0, the information that P0000L7 is loaded on one another drive. And if you do the Phobos drive status on VM1, the same thing, but with the 1L7 tape. Then we can try zlocate with the directories. So here we are, delocate MNT24IS. Okay. So located on VM0, we can check the same kind of thing. Okay, so we have the lock, the timestamp. All right. And I can then check for the other ones. Taurus is also on VM0. No issues. And Gemini is the same way. Also, we cannot have here, like we have for tapes, directories that do not answer a host name when we do a locate on it. Why? Because this is all directories are managed in Phobos. For us, a directory is attached, is bound to a host and cannot be shared. Okay, that's kind of design we got from the beginning, and that's why we cannot manage for now shared devices. Okay, and so when we do a PSQL command, so this is a 24 database, and I check from the devices side of a directory, we can see that Arias, Taurus, and Gemini are in VM0 and VM1. Okay, and that's in the IDs, and you cannot change that. Okay, one of our goal for having the shared device feature ready is to kind of destroy this ID, having two fields separated, and then having an ID that can be shared and a drive that can be shared. So dear or like drive, it cannot be shared, but tape can be mounted on different hosts. Yeah, that's the point. Yeah, that's the point. For NFS, one workaround that works with shared directories, if you want to have that, is you can try to have no, that's I would have say drives that have different IDs, okay, but you need to have one medium that is the same. But you cannot do this easily with Phobos for now. I think you cannot do this at all. The only way to do this is to corrupt the database, and that's not wanted. The better plan is to wait for us to work on it, to have shared drives. Then we got what will happen if a get command target an object located on the P0001L7 tape. So when we located the tape, we got VM1 and we are on VM0. So we can have two kind of behaviors. If we get using the best host argument, we will get a failure because we are not the best host, okay? As the locate command returns VM1 because the tape is mounted in a drive on VM1, okay? But if you do not run best host, what will happen is you will wait for the tape to be released by the drive on VM1, and then waiting for the arm to retrieve the tape, load it on one of our drives, mounted it, and then you will get the data you wanted. But this is really time consuming. Okay. So then we can go to locating objects. Oh, there's a typo in the PDF file. So we will list the object. Okay, we are, where is the tape? Copied on both hosts, split on both hosts, on both tapes, on distant here. And for each of them, we try to launch a locate command. Okay. For where is the tape, we have VM0. So that means that the object is likely to be on the tape that is mounted on our side on VM0, so maybe P007. So for that, we can check Phobos extent list. The dash all, where is the tape? Okay. And so what we see is, oh no, this is 02. And this is 02. And why is the object sending something? So this is not the same behavior as the Phobos tape locate. It will try here to send one of the hosts, and if it's okay, if maybe the local host in this case. And so as the tape is not available in any host because this is stored in the library, it says, okay, you can stay here and I will mount the drive. That's it, Guillaume?
I mean, if you look at the content of the tape list, maybe you can see that the tape is not locked.
Yeah, the tape is not locked here.
So that's why it returns VM0.
Yeah, that's the point. Okay, that's exactly that. Okay, so the tape is not available, but we can. And as you are already on VM0, it will give you as a result VM0. Okay, and go with the second object compiled on both hosts and say VM0. So it means this is okay. This is all right. If you have data that is on VM0 and a copy on VM1, in that case, of course, you can still retrieve it from VM0. So when we do the Phobos extent list, we can see that both hosts are so for directory are Taurus, which is on VM0, and Gemini, which is on VM1. As we are in a red one with a replicate count of 2, this is not directly. Is that says this is a replica count of 2? Yes, I think this is this point here. The 2 here means we have 2 replicates. So we have the original and the copy here. And so we can get from the original the data we wanted. Post locate splits on both hosts. So here, what we thought is there will be no chance to retrieve the information. So what they say is one split of the red one object is not reachable by any host. So we fail to locate the object. The resource is temporarily unavailable. And if we look at sorry, we got here only one replicate for the object, but we have the object split in two parts, and we have one part in Gemini and the other one in Taurus. So one part in VM1 and the other part in VM0. So this cannot return a valid host, so the object cannot be retrieved at the moment. So new post locate on both tapes. So here we will have at least one copy on a tape that can be loaded or is already loaded on VM0, and the other one on VM1. Oh no, because this is splits. So as said here, we have an object that is split into two extents. And one extent is currently available on VM0 and the other one on VM1. Yeah, that's right. So we have only one replicate, two extents, so it is split. P0 L7, which is on VM0, 01 L7, which is on VM1. So we cannot retrieve for the moment the resources. If we add instead of 0L7 or 017, 02L7, it will give back VM1 or VM0, depending on which tape mounted, on which mounted tape still remains on the information here. Why you don't wait pos.io in the case of split? Well, the goal of allocate is to be is to get a fast answer. Okay. So here the fast answer is, for now, I cannot suggest you to go to this host or this one. Yeah, that's not a get. If you are in a get and you are not in a best host, you will wait. Okay. And theoretically, the tape will be unmounted on VM1 and then mounted on VM0. Okay. But as this is a locate, that's not what we wanted. Locate is just a fast answer and saying to you, now I want to retrieve my object. Where can I go? The answer at the moment is sorry, nowhere, because tapes are mounted on different hosts.
And also the case that's shown here is for an object that when it was written, there was not enough space on the tape. So the object was split in two parts. And that behavior is supported by Phobos, but it should not be the norm. So the locate should not fail for most of the objects that you want to read.
Yeah, and more replication you have, more you will have good locate candidates also. Okay, that's an exercise with bad examples, just to let us think about that. And so for the last object, both locate on this and here. But VM1, that's right. This and here meaning this is Gemini, which is on VM1. So it says, oh, oops. Right, which is on VM1, so you cannot access it yet. But if you send your request to VM1, this is not an issue. Okay. So I think that's all for the locate feature. You have any other questions? No? We can go to versioning then. Okay. Retrieve, okay. As we will have a retrieve, we will start Phobos D. So the first command is to list objects. And we got 3 different objects: useless, to update, and on try. And the first command they ask us to do is to update the object to update by pushing the file, the exact same one from the beginning, etc host. So let's go. So do not forget the dir and then etc host to update. And normally it will fail because this object ID already exists, and so you need to add what we saw an hour ago now, which means the dash dash overwrite. It works. Okay. So now what we did is we updated the object to update with a new version. So for that, we can check. For instance, if I object list dash o whole, we can see that to update is that already has its version 3. Okay. And if I list the deprecated version, to update version 2 was just made a minute ago. Okay, so that's our overwrite action that push this version of the object in a deprecated state. And so yeah, the overwritten version still exists in its version 2 here. Okay. Can we retrieve the version was of the object to update? As we saw on the slides, we can do Phobos get dash dash version 1 to update and send it to TMP. I think TMP already exists. Yeah. Okay. All right. Cat TMP, that was version 1. Okay. And so you get some logs here to say that you really retrieve the to update object version 1. Okay. And then you can push it as a new object if you wish. Or overwrite the third version in case you get some errors with the second and third version. Okay. So that's basically how you can update an object with new version and then check them. Okay. And so here you can see that we have 2 deprecated versions of the object. We got a deprec time, and as said, if we have a policy that say, okay, in 1 month from the 21st of February, we can repack the objects that are deprecated. So there is a chance that in 1 month, the object will not be available anymore. Okay. What we want with those kind of policies is to ensure that we add minimum quality of service, meaning we say, okay, each deprecated version lives at least 1 month. It can live 1 month, 2 months, 1 year. It depends on the repack system, the garbage collection mechanism, but at least you have it 1 month, and see if you have more months, so it's better for you. But we do not ensure that. Okay, we can do to the next topic, adding and deleting objects. Yeah. Okay. So we will create and add one directory to the Phobos system format and unlock it. Okay. Here we are. Add an object to the system. Or maybe we can send TMP. Hop. So if I do an object list, okay, my object was given a new UID. Okay, new version 1. And then they ask me to delete it using del. Okay. All right, the operation succeeded. And if I do an object list minus whole, said I don't have anything because the object is not alive anymore. But I can still see the information about it using the deprecated flag. Here we are. So this is the same, sorry, same UID, same version, same ID, user metadata, which were empty, and the timestamp at when the object was set as deprecated. Okay. Then we can cancel it. Oopsie. Saying this object is a no ID. And then delete works. It means that if I list deprecated, I don't have anything else. And the same object with same UID and version is back again alive. Okay for everyone? Okay, we can go through the 8th exercise. Yeah. Okay, we need daemon. Okay, so here we are asked to list subject. Oh. I got to start Phobos D for the same of DB between two exercises. Yeah. Yeah. There is a possibility that the previous exercise is corrupted, but I think the new one is good. Hopefully, this is not something you are likely to do in your systems to move through different databases. Normally, you only have once. This is something we got natively with our scripts and allow us to do some regression tests and also some tutorial learning sessions like this one to easily go from one to another. But that's not something you will see in your production systems. So for both object lists. Okay, so I have removed the 3 and to remove. I can maybe list some of the information in case. No, okay. Each of them is a first version of the object. So we can delete the object to remove. Okay, this is deleted. Then we will list them. Okay, so I got remove the 2, remove the 3, and to remove. All right. So the to remove we just delete is in the deprecated table. Then we want to consider the deletion of objects remove the 2. Oopsie. And remove the 3. Oh, that failed. And that failed saying that remove 3 already exists. And if we check on both tables we have here, remove the 3 got a UID that starts with F66. And in our alive table, we have one with D1D58, which means that we have here an object that was deleted and the ID was reused for the new object remove 3. So we can't undel OID remove 3. Okay, as the OID for live objects must be unique. So what we can do is to retrieve the contents of remove 3 and insert it back in the system using put and a new object ID. So let's do this. Close get. We're specifying the UID of remove 3. The UID is remove the 3, and I will write it on the mp2 file. Successfully retrieved. Yeah, was deleted. Thanks. And then to add it on a repository. So this is the mp2, and I can say I'll remove the 3, for instance, UID, no ID that is unique. Oh, and if we check the list, we got all remove 3. And of course, the UID differs as this is now in the same object. Okay. And that's the only way to retrieve old versions or objects that were deleted and that would work in every occasion. Okay. So we will go through the last item of our exercises, the tedious one, which deals with aliases. Up. Changing the configuration for the last time today. Here we are. Start Phobos D. Let's go. So, I didn't read it. Before launching Phobos D, open the configuration file. Okay, I will open it. And look at the definition of the default alias, which is called simple here. We got it here. I think it is in store section. And so alias simple is defined here. Default alias for boot operations with layout equal to red 1 and layout params equal REPL count to 1. Okay, so that means we will have a red one with only one replicate. And we do not define a default family, but it will be the default family of the store section, so tape here. And we do not define any tags, meaning we can use any tapes we got. Okay. And so the goal here is to define 2 new aliases. First one is fast archive. Okay. So we only got one layout, so it will be easy, but we need to have one replicate. We will target directories. And also we'll target fast tagged directories. Okay. And we will also define another alias. So this is simple to configure with the same layout, but more replicates. 3. Family is still there, and we do not need to have tags for this alias. So then they asked me to create 4 directories. Okay. Not 24, 29 slash so 124. Add 29. So 124. Oof. Phobos the format. More unlock. 4. And also what they asked me to do is to tag 1 as fast. So Phobos the update more tags. Fast 29 2 up. All right. So do a list of that minus o name tags, and I can say admin status. Okay, all are unlocked, and we have one that is tagged as fast. Okay, and also I think we have like s.status. Yeah, let's say it's empty, meaning this was formatted because, as you can see when doing a Phobos dir list -h, empty medium is formatted as I return onto it. Else the medium will be marked as blank here. Okay. All right. So I got my 4th directories here. The goal is to add 2 objects to the Phobos system, 1 for each alias. Okay. I got 2. All right. So Phobos put -a or -- alias. Fast archive. TMP to obj fast. Yeah. And the other one, mirror cache. TMP to object mirror. Okay. Oh, there was an answer. So I come back to the previous exercise. Didn't see any possibility to rename a node without get put. Why didn't you implement this function? To rename a node without get put. When you said that, do you say how can I say, a deprecated object or an alive object?
It's an OID, not old.
Yeah. OID, yeah. For both of them, we did not want to. Yeah, maybe deprecated or not. Yeah, we did not think of this feature. Maybe we can think about it, as this is only suggests that to change the ID of an object. I think we have one issue with this. Just need to check it here. If I do an extent list, yeah, the issue is the path of the name got the name of the object. The path of the object got the name of the object. Because when we will have a crash of the DB, the goal is to be resilient enough to just read all the tapes we have on our library and rebuild the database using that. Okay. If we crash, but we add some objects that was changed by the names, okay, we will not be able to retrieve the previous state of the DB, as we will not insert new data on the tapes because we change the name. So that's one bad point. Okay, we want to be resilient and by writing the most data we can on tapes in case we lose the DB. We can still try to think of it with the dev team and see what they say, but that was not a feature that was suggested by our production system or our administrators. They did not see that as vital, as needed. Is there a limitation on the name of the objects? So what I know is the object names are processed to remove some characters because Postgres doesn't like them. I don't remember of them, but I think this is some characters that are used in a SQL request, something like that.
The table in the database is limited to 1024 characters. And yes, there may be additional restrictions, but I don't know.
Yeah, to some characters. But if I don't know. I know we can go higher with the limitation of the number of characters because this is something we define in the way we build our database schema. But maybe the restriction is here because paths cannot be longer than that.
Yeah, on Linux, I think the limitation is 4,000 characters, something like that. So for names. So.
So we have hard limitations. Maybe we can overpass them, but that's not something we want. For us, we think that 126 is enough. And we have Phobos used for like 5 to 6 years now in the Francenomic project. And the limitation of the object name size is not filled yet. So it seems okay. All right. So where was I? Adding 2 objects, one for each alias. Okay, so the Phobos async list.oo is a command we wanted. And what we can see, so I will just focus the right object. Okay. So object fast got only one extent. Okay, one replicate here. And it was on 222, which is the directory that was tagged as fast. Okay, and one file here, one version. And if we check for mirror, we can see that we have 3 replicates. 0, 1, and 2 here, and they were put on tutor 2, tutor 4, and tutor 3, as we had no restrictions on the directories we wanted to use, so we can put them on anyone. So Stefan said for the file name, the length is limited to 255 bytes. Yeah, so 120 for the name of the object. We have then some information about the layout. I don't think this will exceed 10 to 12 characters, but then we have the UID also. So this is like 40 characters, I think. So we have 50 characters removed. If you consider the limit of 255, yeah, you can go up a little bit. Okay, repeat the two questions with the following parameters without defining an alias. So we'll add another object without defining an alias. So Phobos put -fd -l red1 layout params repo count equal 3 et on va l'appeler object to mirror. Oopsie. Yeah, it misses this. Okay. All right. And if I retrieve the information, yeah, we have it written with a replicate count of 3. Yeah, the same directories. Okay. With for the new object. Okay. So that's kind of a longer command. If you can go with an alias, this is better. Okay. And also what you can do, as you have yeah, that's right. So default alias simple. Say, okay, I want fast archive. Be faster, see, yeah, fast archive. Okay. So you can then Phobos put tmp object 3. See the spaces on device. Why? I don't think that's because we'll try, but I don't think this is due to that. Oh no. Why? Because it considers tapes? Oh. See that? If that's the case, I think that's an issue on our side. Okay, that's an issue on our side. So you just see the discovery of a bug. Because I think that when we have an alias as default, we must follow the family of the alias and not the one that is defined as default. So normally it would have worked, but not this time. Okay. So if you had any if you have any questions on one we saw today, because this was the last exercise. So thank you all for attending this learning session.
Thank you, Guillaume. Thank you, Sebastian, for nice tutorial.